For question 2, we have a table showing the probabilities of winning or losing when the Dallas Cowboys are playing away or at home. So for part A, we're trying to show that the events of winning and home are independent. So we're going to show and explain with the probability rules that we've learned. So we're going to start by finding the probability of wins, given that we're playing at home, is equal to the probability of wins. Okay, at home, wins is 0.2. Over the total games played at home is equal to 0.25. And that is equal to the probability of wins. We're going to get that from the table. Now we're going to look at the probability of home games that are wins and show that that's equal to the probability of home. All right, so from our table, we're going to locate this. Home and wins is still 0.2. Over the total of wins, we've got to go to this column, go all the way across, is 0.25. Take your calculator, divide 0.2 by 0.25, and we get 0.8. And we're going to look to see what on the table is given as the probability of home games. And that's going to be all. So we're going to add this column, and it's 0.8. So because those are equal and these are equal, these are independent. So now we're going to go down to part B. And we're going to do the same thing using our table to show that the probability of loss and away are independent. So the probability of loss, given that we're playing away, we're trying to prove that it's equal to the probability of losses, and the probability of away given losses is equal to the probability of away. So I'm not going to show you how to do that here. I'm going to let you follow through by what we did with part A. And if we can prove that these are equal and these are equal, we have independent events. For question number 3, we have a large fruit dish with a 36-inch diameter. It's placed in the center of a banquet table. Now the innermost circle is 12 inches across and is completely filled with apples. So let me draw that here. So if it's 12 inches all the way across, the radius is going to be half of that, so the radius is going to be 6. The next ring has a 24-inch diameter and is completely filled with oranges. So that's going to be here to here. So 12 plus 6 plus 6 is 24. And the outermost ring is completely filled with bananas. So we want to know the probability of randomly selecting an apple from the dish. All right, so let's start by calculating the area of the circle that has apples. Again, we have a 12-inch diameter and a radius of 6. Using the formula for area, pi r squared, we can calculate the area of that innermost circle that's filled with apples. The radius is 6, so the area is pi r squared, or 36 pi. That's apples. All right, the area of the entire dish, this is 6, this is 6, and this is 6. 6 plus 6 is 12, plus 6 is 18. So the radius of the entire circle is 18. So that area is pi r squared, or 324 pi. So we put part, the part we're looking for is the part with apples, over the whole. The pi's cancel. And then use your calculator to divide 36 by 324. We get approximately 0.11. You can write that as 11% or as the decimal. I'll just leave it as the decimal. All right, you're going to do the same thing for part B. So part B is asking us what the probability of randomly selecting a banana from the dish is. So if we look here, the banana section is this ring. Now remember the radius of the entire circle. This is going to be 6 here, plus 6 is 18. So pi r squared, 18 times 18 is 324. So the area of the entire circle is 324 pi. We need to find the area of where the bananas are laying in the dish. So I'm going to change my pen color to yellow. All right, to calculate that, we've got the entire circle. We need to subtract the part that is the apples and the oranges put together. So this radius is 6 plus 6 is 12. So that area is pi times 12 squared, and 12 squared is 144. 324 pi minus 144 is 180. All right, so that 180 is going to be this section that's remaining, that's filled with bananas. So we put part over whole, and then simplify. We can cancel the pi, and then 180 divided by 324 is equal to approximately, I'm going to round it to the nearest hundredth, 0.56. You can write it as a decimal or again as a percent. I'm going to put 0.56. Okay. All right, so it's 0.56 or 56%.